hmm And so yeah, I think it's clear that the vision system is very important, but the robot itself, is that even a consideration? I would assume that you can kind of go with any industrial robot that would fit the needs of the sorting system, or do you have a specific one that you prefer over others?
We use the robot is uh, it's the robot is a mean for moving a hand
Okay.
because there's the robot arm and there's the end effector or the
The
tool at
gripper,
the end
yeah.
of the gripper. The robot is just a commodity product to move that hand in space. Okay, so it doesn't really matter how you move it. Actually, it does and it doesn't. We use Fanuc, which is out of Japan, who has a stellar track record in automation for 40 years now,
Okay,
and
okay.
it's used heavily in automobile industry. We use them because they are robust. You have to understand that it's one of the first time we're actually throwing robots in a completely random environment. Robots were never made to be in random environment. They're usually in pick and place, or well, they know where they are and they know where they're going every time. So
hmm hmm
automation robots have always been used for that. So they do always the same move, and they pretty much here it's different. We're reading completely random material. We're making guesses as to where this piece is in space, and we're sending the robot to go down and pick that thing. And if we screwed up on seeing the environment, we're actually sending, because the robot is blind, we're sending the robot at full speed, and it may collide with something.
Right,
That
right.
never happened. Collision in automotive industry may happen when you set it up, but once it's set, it usually doesn't happen. In our world, we're completely random environment change every second, every minute.
Right.
So we're sending this robot in space, and if we miscalculated where we're going, we could actually bang into material and break the robot. So robustness is really important.
hmm
The other thing we like about robots, like Fanuc, they have a slew of robots, like a catalog of robots of different size. They're pretty much all programmed the same way. They have the same sort of base software like that controls them.
hmm hmm
So that gives us a ability to pick the right robot for the right application. A little bit like we're doing with the vision system to pick the right sensor for the application.
Right.
We're picking the right robot for the application. So robot is sort of a commodity part of our product, but we pay great attention to the choosing. Also payload, I mean, how much
Yeah.
you're going to lift and
Yeah.
that sort of stuff, because our payload changes all the time.
For sure.
Sometimes we could send a robot to pick a piece of wood that is occluded by something else. We think this piece of wood is probably 20 centimeter long, but it's 2 meter long.
Right.
So the robot will see an assumed payload of half a kilo, but actually was a 3 kilo payload that he's actually got on his jaw.
hmm
So all this is new because even Fanuc recognized this. We won the Innovation System of the Year last year in 2020 because Fanuc said, wow, this is the first time we actually see our robots being thrown in completely random environment, and the robot never makes the same move from one move to the other.
Hmm.
Because sometimes he goes there, sometimes he goes there, up, down, and picks on different payloads all the time.
Right. Right.
That's really, there's not that many applications in robotics right now that actually are achieving this. And most of it is driven by vision. So if we have strong vision, we understand the environment, then the collision should be less. Then our needs for robust robots and all that jazz it will be less. But all this to say, the robot is quite important in the overall equation.
hmm hmm hmm
But more importantly, the end effector, the gripper, is also super important because we can have all the most sophisticated computer vision system in the world, recognizing the right item, sending the robot at the right position.
hmm
If you miss the piece when you're actually grabbing it, then you have zero effectiveness. So
Right. Right.
you're not getting anywhere. So the end tool is also needs to be adapted for the application. So I cannot sand to pick out plastic bottles, cannot sand it with a gripper, like a large gripper. So we had to invent a bunch of stuff. Most of people right now in the industry are using suction cups,
Right.
but suction cups are not super efficient,
It's not going to
and
work.
it's ill adapted to.
Yeah.
It kind of works in plastic. It's not that bad, in paper and stuff like that. It kind of works, but in construction and demolition debris, in bags, in we don't. It's kind of it's very difficult. It's not the most appropriate type of tool for waste industry, I should say.
Mm-hmm.